So in chapter 26, we're just talking about chi-square tests. We talked about the first one yesterday. So in a chi-square goodness of fit test, you have some theorized or expected distribution, and you're trying to see if your sample matches that or not. Okay, that's all you're trying to do. Now there's two other tests. We have chi-square test of homogeneity and chi-square test of independence. The mechanics for these two tests are the exact same thing. All right. So you really have to think about what you're doing. So you write the correct hypotheses and you name the right test. On a free response question, if you name the wrong test, you'll name the wrong hypotheses, you make the wrong conclusion, so half your points are wiped out, even though you did the math correctly. Okay. So goodness of fit has a little bit different mechanics, so that's not a big deal. That kind of gets put off in its own little space. But these two need to be kind of separated out. In a chi-square test of homogeneity, you're looking to see if the distribution is the same from group to group. That means you have more than one sample, or you have more than one group. Really just more than one sample. A group is iffy, so sample. So you have sampled men, and you have sampled women for some categorical variable of some sort, and you're trying to see if the distribution for men and women is the same. Okay? So your null hypothesis would be the distribution is the same for each group. The alternative is it's not the same. For chi-square test of independence, the test is looking to see if two variables are independent, but it's from the same group, so it's one sample. We did one sample, and we're trying to see if some variable is independent of the other variable. So maybe in this case, we also have a chart that has men and women and some categorical stuff that we're looking at. But in this case, they all came from the same sample. So I'm just trying to see if gender is independent of what other variable I was looking at. So homogeneity, you have to have two separate samples. For independence, you have to have one sample. If you can get that down, you should have no problems with it. The problem is a lot of the time, you are almost 100% of the time, the problems come with a chart to keep track of all of your counts, right? You have males with blue eyes, females with blue eyes, blah, 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 blah. People forget to read the scenario, and they just look at the chart, and so then they try to make assumptions about the chart, and then they name the wrong test. All right? The charts for both of these could look the exact same thing. If I was doing, again, males and females and eye color, I could have a two-way table, males, females, brown eyes, blue eyes, green, whatever. Right, I got a two-way table, but just looking at the table does not help me to decide if we're going to do a test for homogeneity or independence. I could do both depending on what the scenario said. Again, if we did two separate samples, one for men and one for women, I'd be checking to see the distribution of eye color is the same for each group. That would be homogeneity. If I did one sample of people and then split them into men and women, then I'd be looking for a chi-square test of independence because I'm looking to see if the variables gender and eye color are independent of each other. Does that make sense? Do not just rely on looking at the tables. That will not help you. Generally, it helps you figure out goodness of fit because there's only one line. There's not multiple variables. But for homogeneity and independence, we really have to pay attention. Everyone good? All right, so again, all we're going to do today is we're going to go through some scenarios, and you're going to decide what chi-square test you'd use and why. Now, this includes chi-square goodness of fit. So all these, you have three choices. Actually, the book gives you four choices. It says which chi-square test should you use, or should you use some other statistical test. So make sure you're reading through and thinking about what's actually happening and what's actually asking for. Remember, chi-square tests are for proportions, right? We're looking for a proportion of people that are doing something. Okay, with that being said, everyone good? We're just going to look over some scenarios. Okay, here we go. For each of the following situations, state whether you'd use a chi-square goodness of fit test, A chi-square test of homogeneity, a chi-square test of independence, or some other statistical test. So 1A. A brokerage firm wants to see whether the type of account a customer has, silver, gold, or platinum, affects the type of trades the customer makes, in person, by phone, or on the internet. It collects a random sample of trades made for its customers over the past year and performs a test. So which kind of test would this be? A chi-square test, one of the three, or other? Jacob is correct. The chi-square test of independence. How do you know a chi-square test of independence? Said random sample. So it has one sample, and then they went through and distributed the people into those categories, right? We're trying to see if account is independent of type of trade. Okay? Yeah. So if you wrote the hypotheses, those are your variables. Account type, type of, like, and trade type. That's what you're looking to see if it's independent or not. Okay. On B. That brokerage firm also wants to know if the type of account affects the size of the account in dollars. It performs a test to see if the mean size of the account is the same for the three account types. Some other, because you don't have categorical variables. Size of the account in dollars is a quantitative variable. So be careful with that. You have to have categories because you have to be able to put this into a table of categories, right? So that is an other test. All right, in C, the academic research office at a large community college wants to see whether the distribution of courses chosen, humanities, social studies, or science, is different for its residential and non-residential students. It assembles last semester's data and performs a test. This one is chi-square test for homogeneity, and it's because we're assuming they did a sample of residential and then non-residential students. This is all a little wish-washy, but it also says the kind of wording of the question. They want to know if the distribution is different for those two groups. Questions about these first three scenarios? I've got some more. Is the quality of a car affected by what day it was built? A car manufacturer examines a random sample of the warranty claims filed over the past 2 years to test whether defects are randomly distributed across days of the work week. Goodness of fit. You only have one variable, right? You just want to know if when the claim is filed over a specific day of the week. And it says, is it randomly distributed across the day? So you're saying that the days of the week would be equally distributed, equally likely, would be theoretical. Then your sample, you would split them up into days of the week. So you only had one variable there. So that's a goodness of fit. B, a medical researcher wants to know if blood cholesterol level is related to heart disease. She examines a database of 10,000 patients, testing whether the cholesterol level in milligrams is related to whether or not a person has heart disease. Other, because, right, not categorical. You've got a quantitative variable there with cholesterol level. And then C, a student wants to find out whether political leaning, liberal, moderate, or conservative, is related to choice of major. He surveys 500 randomly chosen students and performs a test. Independent. You have political leaning, and then you have choice of major. So it didn't give you the choices for the major, but you have two different variables. And we have independence because we have one sample of people. Questions about that?